Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. In this video, I will review journal performance evaluation of Python libraries for community detection under social media webs. Journal review performance evaluation of Python libraries for community detection under social network webs. Ini performance evaluation of Python libraries for community detection under social network webs. Next journal name, Indonesian Journal of Computer Science. Volume and page, volume 310, number 3, page 3767. Year 2024. The creator Ahadi and Fitriani. Next, link download. This is link download. Yes. Purpose evaluation of Python libraries for community detection under social problems. Next, reviewer and Faizul Ahadi, reviewer that 20 July 2024. Next, background of the study, the development of social networking. The development of social networking platform has transformed the way people interact. The growing number of social media users generates an amount of data and creates communities among users that are interesting to analyze. Community detection has significant benefit in terms of understanding network structures and providing insight into these communities. However, the abundance of options can make it challenging to select the appropriate library and algorithm. Next, problems. According to Data Portal 2023, the global user base of social networking sits as research for 4.88 billion, equivalent to 60.6% of the world's population. This impact of social media usage generates large and diverse data. Therefore, the processing of social network data becomes very important to gain valuable knowledge from the information contained in the data. Next, research purpose. The purpose of community detection is to understand the network structure and identify groups that have similar connection pattern. Next, data source. To perform community detection, resource and efficient algorithms are necessary. Currently, there are many frameworks and libraries available for processing social network data, such as Network X, iGraph, Scikit Network, CDLab, and many more. Selecting the appropriate library is crucial as it can influence the algorithm's performance in community detection. Next, research method. This research is conducted by comparing the performance of 4 libraries, namely Network X, iGraph, Scikit Network, and CDLab, in community detection under the set obtained from the start called SNAP repository using two algorithms, Bluefin and label propagation. The evaluation of library and algorithm performance is carried out considering several factors such as runtime, memory usage, and modularity. Next, object of research. This study evaluates the performance of community detection algorithms on social network using several database libraries Considering runtime, memory usage, modularity, and user-friendliness, the community detection algorithms to be implemented are low-fan and label propagation. The libraries to be used are Network X, iGrep, Scikit Network, and CDLab. Next, result. The result obtained from this study include measurements of runtime, memory usage, and modularity from implementation using the low-fan algorithm and label propagation. Next, result advantage. The advantage of this research include: first, topic relevance. This article discusses the use of algorithms and libraries for community detection in social networks, a topic that is very relevant and important in today's digital era. Next, powerful data and source. The article use data from Data Reporter 2023 and the study for Snap repository, which are credible and well-known data source. Next, detailed comparison. This article compares several popular Python libraries: Network X, iGrep, Scikit Network, and CDLab. In terms of runtime, memory usage, and modularity, this provides deep insight into the performance of each library. Next, algorithm explanation. The article explains the two main algorithms used for community detection, namely loop-back and label propagation, and how they are implemented in various libraries. Next, evaluation and analysis. The article presents direct result and in-depth analysis of the performance of each library and algorithm. Next, conclusion and recommendation. The article provides clear conclusion and recommendation about the most efficient libraries and algorithms based on the evaluated criteria. Next, research shortcoming. The research shortcoming of this research include: first, complexity. This article is quite complex and technical, which may be difficult for readers who do not have a background in social network analysis or Python programming to understand. Next, implementation limitation. The article only used algorithms, loop-back, and label propagation, and does not cover other community detection algorithms that may be relevant. Next, limits focus on performance. The evaluation focused more on performance, runtime and memory usage, and modularity, while other aspects such as ease of use, community support, and library documentation were less discussed. Next, testing limited to device specification. Testing is carried out only on one type of device with certain specification. The result may differ from on device with different specification. Next, dataset variation. Although it used several datasets from the Stanford Snap repository, this article may be richer if it covered a wider variety of datasets to test the performance of libraries and algorithms in various contexts. Next, source of limitation. The article mentioned some limitation in previous research, but does not provide many solutions or ways to overcome this limitation. Next, discussion. Based on the experience gained during the implementation of libraries in this study, it was found that all for community detection libraries used, namely Network X, iGrep, Scikit Network, and CDLab, fall short of the research when especially in profiling function for open and pattern propagation algorithms. These libraries also have good documentation that is easily accessible through their respective official websites, thus aiding in learning about them. Network X and iGraph, which have long been used in graph network analysis, offer a wealth of learning resources that facilitates new users in adopting and implementing them in various skills. This is contrast with circuit network and CD lab, which are still relatively new in their application. Thus limited learning results was their own challenge. This research also has difficulties in the implementation process, which require parameter adjustment and a depth understanding of the input format required by each library. For example, the need to convert a GNC matrix into C as a composite space row format to be processed by function in circuit network indicates a higher level of complexity in the data preparation stage. Integration between several libraries, such as the use of the Network X module by circuit network and CD-lab for graph creation, leads to increased memory usage and larger execution times. In contrast, iGraph with its independent graph creation function offer potentially more efficient performance solution. This discussion highlights the importance of choosing the library based on project needs, the availability of learning resources, and system performance requirements. Although libraries offer the necessary function, deep understanding of their strengths and weaknesses can help optimize the implementation process and minimize potential barriers. Okay, the journal review has been complete. If there are any mistakes in word, language, and pronunciation, I apologize profusely. That's all for my video. See you next time and goodbye. Wassalamualaikum warahmatullahi wabarakatuh.